Welcome and hello. This is a video exercise in MODSIM, and in this exercise, I've titled this one called Link Cost versus Node Priority. In this exercise, we will look at the relationship between node priorities and link costs and show how those values affect the network flows. All right, what I have on my screen here is the MODSIM interface. Let's go ahead and get started. Go File, New. Here is a new network all ready to go. I'm going to start by clicking on a reservoir. So I'll add a reservoir here. And then downstream of that, I'll have a consumptive demand, which is the purple square, and then the network sink downstream of that. I'm going to zoom in here and then rename the reservoir, extra sink, to res1. And then the demand, I'll call that D1. And then the sink, I'll just leave that labeled as sink. Okay. And I'm going to connect these with a link. So the flow from the reservoir, will be down here, flow to the demand, and then the demand downstream to the sink. Next, I'm going to add properties to my different elements, starting here with the reservoir. So right click and properties. I'm going to set the maximum reservoir volume to 200,000 acre feet. The minimum will be 50,000 acre feet, and then the initial will be 150,000 acre feet. So here are the units. I'll just keep it right there at acre feet. And then the priority, I will set that to 100. So the default value is what I want. All right, I'm also going to go over to the targets tab and then set the target volume down here at the bottom to its initial volume of 150,000 acre feet. Here are the units, acre feet. So that's good. That'll be the target all year long. And I'm going to click apply to save those changes and then click OK. All right, before we update any more properties, I need to remember to save this network. I'm going to go to File, Save, okay? Then navigate to your project directory. I'm going to call this one exercise 14.xy. All right, so that's saved. All right, let's go down to D1. This is our demand node. I'm going to go right-click, Properties, and then for the General tab, I'm going to set the priority here to 90. And then I need to add a actual demand value. So for time series tab, I'm going to say it's a constant 10 acre feet per month is the demand. Okay, click apply, click OK. And now what I have is my reservoir that's full of water, and it has a priority of 100 to retain that water to the next time step. However, demand D1 has a priority of 90. So without any link cost, I believe the default cost for a link is 0. Yep, there it is. If I run this simulation, we should have 10 acre feet per month flowing through this link to demand 1. That will minimize the objective function. I'm going to click save and then go ahead and run the simulation. Click OK. Okay, so that ran. Let's just go ahead and check out the link flow here in link res1d1. And here is the plot, and then here is a constant 10 acre feet per month all year long. I should probably mention that the network settings are such that the simulation is a 1-year duration. Let me click on network settings here, and then just bring up the time step tab. So the simulation is for the entire year of 1980, both the data and the simulation, start and end date, and then the time step is 1 month. If we look at the results, we should also see the reservoir volume slowly decreasing. So let me bring that up because we have a constant 10 acre feet per month flowing out of the reservoir, but we don't have any inflows into the reservoir. This particular plot is showing the reservoir release of 10 acre feet per month each month. But if I click on the left axis and change that to volume, boom, here we see this blue line is the reservoir volume. Don't think it's empty though. The units here on the left axis say that it goes from 150,000 acre feet down to 149,880. So it only lost 120 acre feet over the course of that year. So far in this exercise, we've only been dealing with priorities. Like the reservoir has this priority in the general tab of 100. And then similarly, the demand node we saw had a priority of 90 in its general tab in the properties box. But the priority is converted to a cost, a negative cost, and then the most negative cost is the most attractive use of water, whether that means retaining water in the reservoir for the next time period or serving a downstream demand. And the equation to convert priority to cost is found in the user's manual, a number of locations. Here it is on page 49 of the PDF file, and it's equation 17 here. This is about the demands. The cost right here, C sub k, equals negative, and then the quantity 50,000 minus 10 times this DEMR sub I value, which is the priority. So that priority DEMR sub I is between 0 and 5,000, with lower numbers representing higher priorities, i.e. larger negative costs. So if you have a priority that's very low, like 1, then you're going to have a very low cost. That would be 49,990. But if you had a very large priority number, DEMR subscript I of, say, 5,000, then that would equal out, you'd have a cost of 0. These costs are available to view for the demand nodes and the reservoirs in the cost analysis table. So if you go up to MODSIM and click on cost analysis, and then for the radio button, you select node. Here we have a table of nodes. There's the sink, there's our demand node D1 and our reservoir res1, and then the type, and then the priority. So we have 100 priority for reservoir 1, 90 priority for demand D1. And then this last column here shows the NAT flow step cost. We could just call that cost. And that equation that we just saw in the user's manual takes the priority of 90, converts it to this cost, takes a priority of 100, converts it to this cost. And because the cost of the demand was more negative, that's why the demand was satisfied. We can also change the priorities and hence the costs in this table directly. So I've got the priority for demand node D1 highlighted. If I just type in 80, for instance, and then enter, boom, the cost updated to a larger negative number. Now it's negative 49,200, twice the difference that it used to be from the reservoir NAT flow step cost. In addition to the nodes, we also have costs associated with the links. So if I click on links, and then let's reformat this first column here, we have two links, res1 D1 and then D1 to the sink that are labeled here. They currently have 0 costs associated with them, but I can also make edits in this table. Say I wanted to increase the cost from res1 to D1. Let's go ahead and make that 105 and then hit enter. Then the NAT flow step cost, which is this far right column, has updated with the exact same value. All right, that saves automatically. I'm going to go back to the nodes real quick and then change this priority back to 90, which is where it started at. Enter. Now the difference between res1 and D1 is 100 on the cost, which means the water will flow from the reservoir to our demand node D1 as long as the cost of this link is less than this difference, less than 100. Well, what you just saw over in the links was I assigned that link a cost of 105. So now if I rerun the model, then I will have 0 flow through this link. But if I come back to change the link cost to something less than this difference right here, then the flow will occur. The demand will be satisfied in this node D1. So let's go ahead and save and then run it and confirm that link cost of 105 is too large for MODSIM to want to deliver that water. Click OK, and then save, and then run MODSIM. OK, that ran. All right, let's check out the flow through this link now, graph, and we have to change the units to flow. Boom, and there's no flow. Now, real quick, let's change that link cost to a value less than the difference between the cost of the demand and res1 nodes, which is properties, and then we'll just change it to 95. So this is a little bit less than 100. Apply, OK, go ahead and run it. OK, that ran. Now let's go right click and graph. Boom, here is our 10 acre feet per month of flow through that link. Next, what I want to do in this exercise is add another demand node. So I'm going to remove this link and then go with consumptive demand. I'm going to move the label to the side. I'm going to call this D2. And then I'm going to connect it with a D1, D2 link. And then finally a D2 link to the sink. There it is. For D2, I'm going to initialize the properties the same as D1. So right click, properties. In general, I'm going to say the priority is 90. And then for the time series, I'm going to say it's also has a demand of 10 acre feet per month. Apply and OK. Let's go back up to our table, our cost analysis table, and then click on nodes. All right, now we have a new node, D2, and then it has the same priority of 90 and 90. And you can see the NAT flow step cost is right here. So our two nodes, D1 and D2, are identical. If we click on the links radio button right here, We now have 3 links on our network: res1, D1, D1, D2, and D2 and to the sink. If I go ahead and run the model as it is with a link cost of 95 between res1 and D1, I should get a fully flowing 20 acre-feet per month and 10 acre-feet per month, satisfying both demands at D1 and D2. So let's go ahead and do that and then come back to the tables. Let's go ahead and run. Okay. To view the results a little quicker, I'm going to go MODSIM graphing mode, click on the first link, res1, D1. Okay, move that to the side. And then the second link, D1, D2. Boom, here are our flows. As expected, we have 20 acre-feet per month and 10 acre-feet per month. All right, I'm back in the links table. I'm going to make a quick change here to this first upstream most link, res1 to D1. I'm going to change it to 105. Go ahead and pause and think what you expect to happen with the network flows. And I'll tell you right now what's going to happen. That is the additional benefit of releasing water from res1 to D1 and or D2 is only 100. That's the difference in the cost. However, this link right here, res1 to D1, has a cost greater than 100. So just because we have a second demand node here, the benefit of flow to this second demand node is not additive with the first demand node. It's just as much of an incentive because the priority is the same. Okay, so enough talk. Let's just go ahead and run it and confirm that we will have no flow in the network. So I'm going to click on the link res1 D1, click on the link D1 D2, and in both cases we have no flow. All right. Next, what I'm going to do is just modify the priority here at D2. Now, originally it was set to 90, just like D1. Now I'm going to set it to 80. Okay, apply and OK. With D2 priority set to 80, it's now 200 cost less than the reservoir 1, which means any link cost that's less than 200 will still get flow to this node D2. And any cost less than 100 would also deliver to D1. So right now our priorities are 100, 90, and 80, with the link cost right here at 105 and a link cost between D1 D2 at 0. What's going to happen is we're going to have a 10 acre-foot per month flow through both links res1 D1 and D1 D2. D1 will not be served any water. Go ahead and confirm that by actually running the model. Okay, so that's ran. Here is the flow from res1 to D1. It's 10 acre-feet per month. And then from D1 to D2, also 10 acre-feet per month. If you're curious about this last link, we can click it as well, D2 to the sink. There it is. And then let me just go ahead and isolate that series of data. Yeah, no flow from D2 to the sink. The reason why D1 didn't get any demand satisfied is because the benefit of 100 compared to the cost keeping the water in the reservoir was 100 as opposed to the cost of 105. Let's go ahead and modify the link cost from res1 D1 to less than 100. Let's make it, how about 75? Apply. Okay. Now we'd have 20 acre-feet per month and 10 acre-feet per month. Let's go ahead and increase the cost of flow in this second link, D1, D2, to something greater than a value where the sum of the link cost exceeds that additional cost advantage to D2. So something, a greater number greater than 200. How about we set it to 150? So right click, properties, and then for the general tab, I'm going to set 150 for the link cost, apply, and OK. Now I expect to have 10 acre-feet per month and 0 acre-feet per month. Go ahead and confirm that is done. Okay. All right, so let's go ahead and check out the results. Here's the flow from res1 to D1, that's 10. And then the flow from res1 to D2 is 0, because the cost from res1 to D2 is, what did we say, 75? Is 75 plus another 150, that's 225. That is larger than the benefit received or the reduced cost from res1 to D2, which is only 200. Well, that's it for this exercise. We created a simple network and we looked at how the priorities are converted to costs and then how the costs dictate what the flows are through the network.